Welcome back, grade 11s. We've got our proof here on tangents from same point. But before we get to our proof, we just need one axiom. And our axiom is something that we're just going to state to be true, and then we're going to use it later. Well, there's a bit more to axioms, but let's just take that as our meaning for now and say, if we are given a tangent to the circle, let's actually rather highlight that tangent, and there's our tangent, and we draw a line from the radius or from the center to the tangent, so we draw a radius. If we are given that, then it must be at 90 degrees. Okay, and conversely, that if we draw a line that's perpendicular, then it must be a tangent. In other words, not something like that. That wouldn't be a tangent, or this didn't touch the circle at all. Okay, so the one that we need here is we're given a radius that touches a tangent, and therefore it's going to intersect at 90 degrees. They'll be perpendicular. And our reason for that is going to be tangent radius, which we're going to shorten to tan rad. Okay, so that's something we need. We need that axiom, and we need that to do our proof. So in our party hat over here, we've got two tangents drawn from a single point, and they obviously intersect the circle just once each. So our first one is PA, and our second tangent is PB. And what we need to prove is that PA equals PB. That's what we're trying to prove. And how are we going to prove this? Remember, for the other proofs, we want to remember the general idea, and then we'll fill in the details after that. Is very, very similar to all the other ones we've done. All the other ones, we've drawn radii. And in the first one, we ended up with triangles that were the same, they were congruent. Okay, so let's follow the same line. So kind of in brackets, the way we're going to do is we're going to do congruent triangles again, and we're also going to construct radii. So let's construct those things that we need. So let's draw it nice and neatly here and go dung. We're going to construct that radius, and we're going to construct that radius. They feel like the obvious radii to construct, so let's construct them. We're also going to use congruent triangles, so we need to create our congruent triangles, and I'm going to construct a line from O to P, creating two triangles that we're hopefully going to prove are congruent. Okay, let's now capture what we've done here. So first of all, we construct radii OA and OB, and we also constructed line OP. Now, using the axiom that we've just learned about, this must be 90 degrees and this must be 90 degrees as well. I'm going to call that B1 and A1 rather than calling it PAO and PBO respectively. So let's write that down. A1 equals 90 degrees because of tan rad. And similarly, B1 equals 90 degrees because of tan rad. Okay, now we need to show that these two triangles are congruent. There's a right angle. So it feels like we might use right angle hypotenuse side. Well, let's see. They've both got a right angle. The hypotenuse is OP. Well, that's going to be the same in both triangles. And this side AO is going to equal this side OB because they're radii. Okay, so let's just capture that idea. Let's capture the congruency. In triangle, I'm going to start with the left one. OAP, and triangle. Order of letter doesn't matter here, but it makes sense just to get it right. OAP, center, circumference, point outside, center, circumference, point outside. OBP, we can show three things, giving a reason for each, and we're going to sum up and say, therefore the triangles are congruent. In other words, they're pretty much the same, or they are the same, right? And our reason, we already know we're going to use right angle hypotenuse side. Well, let's start with the right angle. The order doesn't matter, but A1 equals B1. Well, we showed that above, so I'm just going to say shown above. Then let's go to the hypotenuse. OP is indeed just equal to itself because it's a common side. And the other side we can show is that, well, OA and OB are going to be equal to each other because they are, that's a great B, OB because they are both radii. Okay, so therefore the two triangles are congruent. Well, if they're congruent, they're the same in every manner. So this side must equal this side. So therefore, PA must equal PB. In other words, whenever we're given two tangents that come from the same point, they must be equal to each other to the point where they touch the circle, or the circumference of the circle. Okay, and one other thing that may be useful, we'll see it in the examples. So we're going to use that theorem quite a bit, and we're going to do some examples on that. I'll see you in the next one.